Assalamualaikum, dear friends. Welcome to my YouTube channel, Math Expert Students. Please subscribe my YouTube channel. Click the bell icon. And students, one important thing: if you have any question related to these topics, you can send us via email your question, or you can post in the comment section. We will solve this question and send you a link. Today we will study about the derivative of the Laplace transform. As you know that students, when we apply the Laplace transform on a function f of t. For example, I am writing here the Laplace transform of Laplace transform of f of t is equal to integral 0 to infinity e raised to power minus s of t, okay, f of t, and then dt. Now students, and this thing we call that f of s. Now if I want to apply the derivative d by ds of f of s, it's mean that I want to apply derivative here 0 to infinity e raised to power minus s of t, f of t, and dt. Students, one thing important here I want to mention: if I want to apply the derivative on the integral, this is an integral, okay, and I am applying the derivative on this integral, okay. Now for this I use the Leibniz rule. Using Leibniz rule, Leibniz rule say that if I have a function d by dt and I want to apply this derivative on this integral g1 of x and g2 of x, and here I have d by dx for your easiness. I have here d by dx, okay, and f of d dt. So I can apply like this: f of upper limit, which is equal to g2 of x, and then derivative of the upper limit g2 prime of x minus f of g1 of x and g1 prime of x plus integral g1 of x, g2 of x, and then d by dx of f of t and dt. This is the way we can apply the derivative on the integral by using Leibniz rule. Now students, we use this rule in our problem. D by ds of f of s is equal to d by ds of integral 0 to infinity e raised to power minus s of t, f of t, and dt. Students, when we apply the upper limit here, you say that f of infinity e raised to power minus infinity, and you know that this goes to e raised to power, like I am writing here, e raised to power minus infinity f of infinity, okay, which is approaches to 0, and upper limit is infinity, so its derivative is also 0, minus lower limit is also e raised to power minus 0 f of 0, which is equal to, when we apply the derivative on the 0, so lower derivative is also 0, plus integral 0 to infinity d by d s e raised to power minus s of t, f of t, and dt, okay, which is equal to 0 to infinity d by ds of this function, which is equal to minus e raised to power minus s of t, t, f of t, and dt. And we can write this minus integral 0 to infinity e raised to power minus s of t, t, f of t, and dt. And you know that this is equal to minus Laplace transform of f of t, t, f of t, okay. It's mean that Laplace derivative of the Laplace transform is equal to minus Laplace of t, f of t, okay. If I have, like, I am want to generalize this, Laplace transform of t f of t, which is equal to minus d by ds of Laplace transform of f of t. Okay, small f of t. Okay, if I have here t ka square f of t, it's mean that this is equal to minus d by ds. Okay, minus d by ds Laplace of t f of t. Okay, minus d by ds minus d by ds of, which is equal to Laplace of f of t. Okay, which is equal to minus d square by ds ka square, sorry, plus d square by ds ka square Laplace of f of t. It's mean that if I want to generalize this, it's mean that if I have a Laplace of t raised to power n f of t, so I can write this in this form, minus 1 raised to power n dn over dsn Laplace of f of t. Okay, students. Simply, if you want to apply the Laplace transform on the derivative on the Laplace transform, so I use this rule. If you are new here, please do subscribe my YouTube channel, click the bell icon. And if you have any problem related to this, you can send us via email. We solve this and send you the link of the video. Thank you.